The next portion of Chapter 9 is going to be estimating confidence intervals for a population mean. So it's the same thing as Section 1. We're doing mean still, but this time the key is that the population standard deviation is unknown. And chances are when you're doing your own statistics, for research and such, you probably won't know the population standard deviation. So this is the more likely test that you would run in your own project or statistics or research and so forth. Now the difference is we're going to use the test known as the t-interval, and it's in the same place in your calculator. It's the second choice. Instead of z-interval, it's the t-interval. Now if you look at the two graphs here, the one on the left is a graph of a z function, and the one on the right is a graph of the t function. And a couple things that you should notice is they're both symmetrical, so we have that somewhat normal shape going on. But in the t interval, the one on the right, this is a lot more spread out. There's a larger tails here. All right, whereas this is a lot more condensed. All right, we go from -10 to 10. It's very short and condensed. And so that's one of the things that happens when you move into the t-interval. You have a wider spread, and it's slightly different shaped, but still symmetrical. Now, this graph here is an overlay of t-intervals with the normal curve, which is the z-interval. And you'll see that the orange line is with a sample size of 5, and we can see that over here in the area, the tails are much larger than they are with the normal curve, the blue line, and it's also shorter in the center. And then as we increase to n equals 15, you can see that the tails get a little bit smaller and that the top gets a little bit higher. And so in summary, what ends up happening is that the larger your sample size, the closer to normal we are. And so eventually, if you get a large enough sample size, it won't matter if you're doing the t-interval or the z-interval, they will ultimately become the same. Now, before we get into actually calculating the intervals, we're going to talk about determining the t-value. Now, back in Chapter 7, we saw this, but we were looking at z-values instead of t-values, which are ultimately very similar in concept. So this question here says, find the t-value such that the area under the t distribution to the right is 0.2, assuming 10 degrees of freedom. Now, what that degrees of freedom means is really irrelevant. It's going to ask you to plug it in. It will always be given to you. So it's not really anything you have to worry about. You just note that you have to type it into the calculator. So that is find t 0.20 with 10 degrees of freedom. Now, if you recall, when we were finding z values back in Chapter 7, we used inverse norm, right? Well, we're going to use a very similar thing. We're going to use inverse t. And just like inverse norm, the inverse t can only do areas to the left. And so if we want to the right of 0.2, all right, then we have to actually do 0.80 because 1 minus 0.2 equals 0.8. And so if we go inverse t in our calculator, 0.8, and then that's the 10 degrees of freedom, it would tell you 0.8791. And it's the same place that you got the inverse norm. Menu 552, I think, was inverse norm, I believe, or 3 was inverse norm. And somewhere right around that same area, you will find inverse t right there. So make sure you can go ahead and find that. Pause the video, type that in, and make sure you can locate that in your calculator screen so you can do that for your homework. Now we're going to get into calculating some confidence intervals. So this example says the pasteurization process reduces the amount of bacteria found in dairy products such as milk. The following data represents the counts of bacteria in pasteurized milk for a random sample of 12 pasteurized glasses of milk. So that means that N is equal to 12 in our specific example. So they give here that the mean is 6.41 and the standard deviation is 4.55. Now, one thing I want you to know is that in this case, they said S is the standard deviation, not sigma. Now remember, the sigma represents the population. So one thing you want to watch out for is when we're looking at problems on the test, these are all going to be mixed up. And so if a problem gives you S, then you know you're going to use the T interval. If they give you this, or they say the word population, you're going to use the Z interval. So watch out for that, because on the test they'll be mixed up, whereas in your homework all the Z intervals are in 9-1, the T intervals are all 9-2, and so forth. So you want to be careful with that. So watch out for the S or the sigma or the word population or sample to help you decide whether you're going to use a T or a Z interval. And so if we're going to construct a 95% confidence interval, we have to go into our calculator, into the menu. So make sure you can do that. Get to the T interval. So that's menu, and you have your handout to go through the calculator instructions, but that's menu, 6 statistics, and then 6 confidence intervals. And then you want to make sure you choose T interval this time. And so the 95% confidence interval, so that's your CI level, should give you the answer of 3.52, 9.30 with a margin of error of 2.89. So go ahead and pause the video and make sure you can get that calculation before moving on. Next example says a Gallup poll conducted May 20th to 22nd of 2005 asked 1,006 Americans during the past year about how many books, either hardcover or paperback, did you read either all or part of the way through. Results of the survey indicated that the mean was 13.4 and the standard deviation was 16.6. Now note, again, they use the S, so we know we want to use a T interval for this. And so we want to construct a 99% confidence interval for the mean number of books that Americans read either all or part of the way through, and then we're going to interpret that. So we'll practice that. So first thing I want you to do is pause the video, make sure you can type this into the calculator and get the correct interval. All right, so moving on, the answer that you should get would be the 12.05, 14.75. All right, and the margin of error is 1.35. That's a pretty low margin of error. So now let's talk about what does this mean. So how do we interpret the interval? So here on the screen you should see the interpretation. I typed it out to make it faster. And it says, we are 99% confident that the mean number of books read by Americans last year was between 12.05 and 14.75 books. Now notice, we always start by stating how confident we are. That's the first thing that you want to do. 99% confident. And then what are you confident about? Well, we're confident about the mean of what books read by Americans. Be specific in the context, and then you always end by saying between and then what we're talking about. So we'll always say books. So make sure in your interpretations that you are specific about the context that you're discussing. The final section of Chapter 9 is Section 9.3, which is all about the confidence interval of a proportion. Now, this is essentially the test that you would use if you were working with qualitative variables, where you can't actually plug the numbers in and get a mean or a standard deviation. Instead, you're using what we talked about in Chapter 8, a point estimate, to look at proportion of individuals with a characteristic. So you can't find the average of colors, but you could find the average number of people who have that favorite color. So you can find the proportion or number of people or percentage of people with a certain characteristic. And so that's what we're going to be characterizing in section 9.3. the example that we're going to start with is we have in July of 2008, there was a poll that asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder, and the results were 1,023 were in favor. So the first part is, can you obtain a point estimate for the proportion of registered voters nationwide who are in favor? So remember, the point estimate is p hat. We learned this back in chapter 8. Is 1,123 in favor out of 1,783 who were asked. And if you type that into the calculator, you get 0.629, which is essentially 62.9% of the people who were asked were in favor. Now, the confidence interval that we're going to be using this time is the 1 proportion Z interval. All right, so this is in the same area, menu 6 confidence intervals. And then this is 5 1 proportion Z interval. And remember, the calculator commands for all of these are in your handout that has all the formulas and calculator instructions that you can use. Now, one of the things that you have to recall from back in section 8.2 is that for this to work when you're working with proportions, that you have to be using n times p times 1 minus p has to be greater than or equal to 10 for this to work, meaning you have to sample enough people or subjects to make this work. And then the second criteria is that the sample size has to be less than 5% of, and that n is the population. And that's so that everything is independent, so we know that we're not getting any crossover or influence in our results. So we're turning back to our previous example about the 1,123 people in favor of the death penalty for those convicted of murder. They asked us to obtain a 90% confidence interval for the proportion of voters who are in favor. So that means our P is 0.63 because we calculated that on the previous slide. So our P hat 0.63. And then so we need to check first that N times P times 1 minus P is less than or equal to 10. So if we plug that in, we would get 1,783. Then we need to times that by the P, which is 0.63, and then 1 minus P, which is 0.37, which gives us 415.6, which is definitely greater than or equal to 10. And then obviously we only sampled 1,783, and that's definitely less than 5% of all Americans. So I'd say we're definitely below 5% of the population there. So now that all the criteria are met, now we can go to our calculator and do the 1 proportion Z interval. So here's the information you're going to need for the calculator. So go to your calculator, make sure you can plug this into the correct 1 proportion Z interval, and you should end up getting the 0.611, 0.649 with a margin of error of 0.0188. So go ahead and pause the video, make sure you can get that calculation, and then continue on from there. Now, just to make sure we understand what this interval stands for, all right, so remember from the last examples, this means that we are 90% confident that the proportion of registered voters who are in favor of the death penalty for persons convicted of murder is between 61.1% and 64.9%. So that's where we believe the population falls somewhere within that interval, which is a very low margin of error. So that's definitely good for interpretation purposes. Now, before we do our final example, I want to just summarize what we talked about in chapter 9 to make sure that we get this down, because you're going to have to cover all of these and they'll be mixed up on the test. So section 9.1 was the Z interval. All right, and you use this when population standard deviation is known. So you want to look for in the problems either this symbol or the word population standard deviation. So that's when you know to use the Z interval. In 9.2, is where you use the t interval. All right, and this is where the population standard deviation is unknown. So what you want to look for with these ones is S instead of the sigma. That's your standard deviation. So there's no fancy sigma. That's how you know that it's the other one. And then 9.3 is the proportion Z interval. And that's when you're talking about proportion. So that one's totally different from the other two. And remember that these two here are talking about the mean. So these are all about the confidence interval for a mean, whereas 9.3 is the confidence interval for a proportion. So when it comes to the test, you're going to have these mixed up. It's going to say calculate a confidence interval. You're going to have to decide, do you want to calculate a Z, a T, or a proportion? So you have to read it and look for those clues. All right, and our final example then, we have a Zogby interactive survey conducted February 20th to 21st, found that 1,322 of 1,979 randomly selected adult Americans believe that traditional journalism is out of touch with what Americans want from their news. So the first question is obtain a point estimate for the proportion. So the point estimate is p hat 1322 divided by 1979. All right, divide that out, we get 0.668. So that's our proportion. Essentially, that's kind of where we feel like the average or the population would fall. Now, B says verify the requirement, so that's the NP 1 minus P greater than or equal to 10. So N would be 1979.668 times 1 minus 0.668, and that equals 438.89, which is greater than or equal to 10. Agreed there. And then would we say that 1,700 or 1,979 is greater than 5% of all Americans? I would say so. So that's definitely greater than 5%. So that means we've met all of our criteria. The last thing is to actually create a confidence interval. So this one asks us to do a 96% confidence interval. So we know that N is equal to 1979, X is equal to 1322, and our CI is equal to 0.96. So then you should be able to go to your calculator and figure out what that is. And just to verify, 0.646, 0.690, those are your intervals. And the margin of error is 0.022. And so make sure you pause the video and put that into your calculator. Make sure you can get that. If not, make sure you try until you get that. And so the final thing is to just interpret that. So how do we interpret that? Well, we would say we are 96% confident that between 64.6 and 69% of Americans believe traditional journalism is out of touch with what Americans want from their news. So you want to write that out. Remember, in context, the confidence interval, and include the interval to make sense of what's going on. So if you need to rewind that to listen back to make sure you have it written down correctly, please do so. And then the final question says, is it possible that the proportion of adult Americans is below 60? Or is this likely? So now, the interval says it's from 64.6 to 69%. So could it be at 60 even though our interval is at 64 to 69? Well, technically, yes, it's possible. Because we only did a 96% confidence interval. So we're only 96% sure that it's in there, which still leaves a 4% room for error, essentially. So it's possible. Now, is it likely? No, it's not likely. Because we're 96% confident. So that's 4%. We only really have a 4% chance of being wrong. So for statistical purposes, 4% chance of being wrong is really good. So we would say it's possible, though it's not likely. The only way it would be impossible is if we had a 100% confidence interval, which is never going to happen anyways. All right, so just to clarify, I want to make sure we're on the same page. The next time we'll be meeting in person will be Tuesday, April 15th. All right, and at that time, I'm going to collect Chapter 8 and Chapter 9 homework problems. We'll take time at the beginning to answer questions and so forth, and I'll be there early, so if you need to come talk to me about any of the problems, you can. But we'll go through those. We'll take a 9.1, 9.2, 9.3 quiz, which essentially you'll have to do a confidence interval, one of each. There'll be mixed up, so you have to be able to determine which one to do. So we'll review, and then we'll review for the test that day as well. So just over the next week, be working on your Chapter 8 and your Chapter 9 homework. Go through these videos and maybe set up some, during our normal class time, maybe set up a meet where a couple of you can meet together, go over homework, help each other out, and feel free to email me with any questions.